Welcome to all. I am Dr. Raviraj, Professor, Department of CSE, KIT Kalangar Karunanidhi Institute of Technology, Coimbatore. I am very happy to explain the topic Phases of Compiler, Course of Compiler Design. Learning objective of this course is demonstrate the functionalities of the various phases of compiler. The cognitive level after completing this particular topic is understanding level in Bloom's taxonomy. First, I am very happy to explain about the compiler. What is compiler? Compiler is a program, it's a system software, can take as a program, a source program as an input, and it will convert into the target program. There are 6 phases of compilers listed out in this particular slide, whose names are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. Each phase has transformed the source program from one representation to another representation. All the phases of compiler communicate the error handler. If any case of errors are identified in any phase of the compiler, that will be resolved by the error handler. Apart from that, they are using one data structure that is called a simple table, which is stored all the identified symbol that is used inside the compiler. First, I am very happy to explain the first phases of compiler. What is lexical analyzer? That is the first phase of the compiler. It receives the input source program and it reads the program character by character. Then it returns the token of the source program as the output. Token in the sense it's a technical term which is indicating the identifier, operator, keywords, numbers, delimiters. For example, here there is one example in this slide, new value is equal to old value plus 12. How it segregate the tokens in the sense, new value is called as identifier, old value is another identifier, equal to is an assignment operator, plus is an additional operator, and 12 is a number. So this likewise it will list out the token for the entire program. In this lexical analyzer, all the data structure they are using behind that means they are using the concept of regular expression and deterministic finite automata. The next phase of the compiler is syntax analyzer. The output of the lexical analyzer will enter into the second phase of the compiler, that is called as syntax analyzer. The purpose of this phase of the compiler is to check the syntax of the source program. If any mistake in the syntax, that mistakes will be identified by this particular analyzer. The algorithm which is used behind this particular analyzer is parsing algorithm. There are 2 types of parsing techniques. One is top-down parsing and one is bottom-up parsing. Top-down parsing means the parsing process takes place from the root and it proceeds towards the leaves. It's an effective method of parsing technique. We have some examples of top-down parsing methods, that is recursive or predictive parsing, non-recursive predictive parsing. Another type of major parsing technique is bottom-up parsing. It will construct a parse tree. It will start from the leaves and it proceeds towards the root. It's an effective parsing technique method. Example of the very famous well-known bottom-up parsing algorithm is shift-reduce parsing. Apart from that, we have operator precedence parsing and LR parsing such as LR, SLR, LALR parsing algorithm. Then the third phase of the analyzer is semantic analyzer. The purpose of the third phase of the compiler is to check the type of the data. Because we are using so many symbols, we have declared so many data type of that particular symbol. The syntax analyzer will check only the syntax, but the semantic analyzer will check the logical error, that is whether the data type is mentioned in that particular program is correct or not. That will be checking in this particular semantic analyzer. Then the output of the semantic analyzer will go to the fourth phase of the compiler, that is called as intermediate code generator. Why we call it as the intermediate code generator means the output of this intermediate code can be understood by both the user and the machine. For example, source program C language, for example C program, that will be understood only by the user. That program will not be understood by the machine. But the machine code is only understood by the machine, that will not be understood by the user. But this kind of intermediate code will be understood by both the user and the machine, so that it is called as intermediate code. Actually, the role of compiler is to convert the source program into machine program. But how it will convert means the help of two steps. First one is the source program will be converted into intermediate code, the help of intermediate code generator. Then next, the intermediate code will be converted into machine. So at the outcome of the second process is we will get the main target code, that is called as machine code. So this intermediate code has been generated the help of this intermediate code algorithm. The example we have given, new values equal to old values star fact plus 1. This is the given example that will be converted into tokens with the help of lexical analyzer. Identifier 1 is equal to identifier 2 star identifier 3 plus 1. Then that will be converted into parsing algorithm that will be checked the syntax error and semantic errors with the help of syntax and semantic analyzer. Then that will be converted into intermediate code as given below. Then that output will go to the code optimizer. Fifth phase of the compiler is called as code optimizer. So main purpose of this code optimizer in compiler means it will optimize the code and increase the performance of the compiler. It will remove the redundancy of information, it removes the dead code and everything. So if there is a possible to optimize, it will optimize the code, then it will make easier to compile the particular program, so that the performance of the compiler has been increased. So this is the example they are given. Previously in intermediate code, the outcome of the intermediate code is 3 lines code: multiply, add and move. There are 3 opcode instructions, but here those 3 code instructions will be reduced into multiply and add. But the meaning of the program is same. The code optimizer will save the meaning of the program. It does not change the meaning of the program. That is the highlight of this code optimization algorithm. Finally, we will enter into the 6th phase of the compiler, that is called as code generator. This is the final phase of the compiler. We will convert the intermediate code into machine code, that is called as target program. We have the final machine code of the source program is 4 lines of code for that particular example. So from this topic we have understand the designer have designed the compiler with the help of 6 phases of compiler. Each and every phases of compiler play some role during the compilation time. Compiler is one of the necessity system software we have. Whatever application software we want to create, definitely we need the compiler to compile the source program, to convert the source program into the corresponding machine, so that we will get the exact output of the given input. Thank you so much for giving the chance. I hope this topic is very much useful for you to understand the basics of compiler, that is the design of compiler. While designing, we have maintaining the 6 phases of compiler. That role is whatever given in this slide. And thank you so much for this opportunity.